Oh, I was noticing that some of these motors, this plastic cap that straps the motor in, that part is larger than others. In this particular case, it was hitting against this part of the frame, pulling the gear further away from this one than it should. So I took a Dremel and routed that out some. I think before I put the files up on Thing-I-verse, I'll go ahead and modify it so that that's cut out more. That's just a heads up that not all these motors are exactly the same. In fact, far from it. But usually close enough to do little projects like this. We'll see if things continue to line up or not line up. And put that in, back it off till it's loose. You don't want it binding, the motors aren't very powerful. So I have these this way, so when we put the ones on the other side, we'll want to make sure that we have them 180 degrees out. So it should be like this. There we go. And this is the front because that's where the body is going to screw on, so this aims down. The legs I went ahead and changed a little bit from the Type 2 clawfoot just to look different, look nicer. Wanted to give it more of a width on the part that sticks out of the bottom of the body to give it a little bit better cosmetic look, and added some taper to the forks. And now there of course is a front and a back to it. We know that this is the front of the mechanism. I have the angled part here to give the illusion that the toe sticks out further. So this part would go on like that. And that would require a couple more number 2 self-tapping screws with some small washers. What do we have laying around? And just screw these on, making sure that they stay loose. If for any reason they bind up, then just back the screw off a little bit. It's not going to come out on its own. You know I hate it when I do that. Find the washer, but I'll never see that little screw. Lose more little teeny screws that way. Of course, it generally only happens when the camera's running because I have to hold everything at such a weird angle and position from what I normally do. That's all good. Let me put the one on the other side. I wish I knew where that little screw was so I wouldn't have to go get another one. But I think I'm gonna have to go get another one. That one's on there. And I'll go grab another little screw. Oh, here it is. I actually found it. That's a first. Lucky day. Okay. So now we've screwed these parts together. We have this part which will screw to the front of the body. We have the taper on the legs on the front side and the straight up and down on the back. So you should look about like this at this point. Now let's do some prep on the body. The body prints like this on your build plate, no supports. And your machine will, there's an indent here that the head's going to glue in just for alignment purposes. But your machine should be able to bridge that. But I did need a hole in the middle in order to do the mouth opening and closing bit. There's a rod that has to pass through, but if I put the rod opening in here now, the machine wouldn't be able to bridge. So what I normally do is the part, and I don't know if there'll be enough light to see in there, the part where the rod goes is marked on the inside, and I'll just take like an X-Acto knife or something and poke it through there and open it up. It's only 0.5 thick at that point. So once you do that, then you can kind of see it from the top side. Then you should be able to take your knife and just hone that out. Like so. I'm trying to square up and clean up the corners. I don't want the push rod to bind on anything. This strange looking thing here, this is the push rod that will go up inside the body. The large flat side will be towards the back. This is the battery box area, so that's the back. So it would go in this way. And you actually have to kind of snap it past that. But see how it's going to fit through that hole. I don't want to put that in quite yet, just so I make sure I don't get glue on it, because we want to take our head, which is in two parts, this being the bottom part, and we'll want to glue that on now. And staying away from that center hole in the part, just go ahead and stick a bunch of glue on there. And again, for the sake of the build and the videos, I'm just using your regular super glues and stuff and the speed set spray. It's true, epoxies and goop and things like that, which take longer to cure, are actually better glues. You can pretty much pop any super glue joint apart if you ever have to pry it, if you work carefully and slow. It's just not as long term. So now we're going to take, as we just talked about, this being the back, see the battery box area, and this is the item that's going to make the mouth open and close. The long flat edge is going to go towards the back. Just going to start the end of it into the hole, kind of see how it's sitting in there, then just push it on past the battery box like that. Just let it sit in there. What it's going to do is those two long prongs on either side, those are going to rest on the top of these two leg pieces. And the reason they're long is because the leg pieces also move. So anytime halfway would be mouth closed, and anytime either one of the legs is up, that will push the rod up. So the mouth actually opens and closes twice as fast as the walking action, for example. Okay, so now you have the upper part of the head, and again I just used two number 2 self-tapping screws, and there's a place right there where the screws are going to go. You just set the top of the head on, and again you don't want the screws tight because you want the head to be able to move freely, so just screw them in a bit. And when you're done, you can move the head up and down. If it sticks, loosen the screws up a little till it stops sticking. Like right now, it won't move. So let's loosen it up a little. Still too tight. if need be, we may have to go, there we go, get the screws loose so it can do that. Then you should be able to reach up in there and push on that thing and actually get the head action. Right? Right. I'm thinking it might be easier if we do the battery box next. Again, I'm using a AAA cell, 2 of them, holder. And I pre-bent these tabs outward so that they're not snapping in to make it easier to get the batteries in and out. And this battery box will snap into this fitting. It's that close of a fit, even without glue or screws or anything. But there is a screw hole provided, and if you have the battery box, it has the hole in the center like this one does. You can then pop a screw in there. I'd already pre-cut the red lead short because I'm going to run mine to a switch. Now if you don't have a switch, no big deal. You can just put the batteries in and out to work as your switch. Let's go ahead and put a screw in that battery box. Just to secure that, like so. Then again on the switch, it's a slide switch. Single pole, double throw, double pole, double throw, doesn't matter, either type of work. The main thing is this about, if you want to fit it into the printed part, it's about 19 millimeters between the two mounting holes. So let's take, I just thought it might be easier to solder this part on now while the legs aren't in the way. So that's why I decided to do it now. I don't know if any of this is in camera, but I kind of need the counter to help hold everything. And again, I just got the switches off eBay, but you can get them just about any place that sells small switches and stuff. And usually you have to buy the screws separately. They're number 2. If they're from Japan type switches, and number 2 metric usually. So what I'm going to do now is solder the short red wire to one of the terminals of the switch. Then the other piece of the wire that I'd cut off that red wire, I'll solder to one of the other terminals of the switch, and that way I can interrupt the power to the motor. And again, I don't know how much can be in camera and how much can't, but I'm kind of forced to solder however I can here. So hopefully some of it will show up. I know it's kind of dark. I could use more lighting. I could use a lot of things. I could use a cameraman. But it's just me and you. So let's make the best of it. There we go. I just went ahead and soldered it to the center terminal because it doesn't really make any difference. And I'm going to tin up the remaining red wire on both ends so that it's ready to be used. While I'm doing that, I might as well tin up the black wire too. It looks like it might already be tinned up, and we'll make sure. Never hurts to flow on some fresh solder. And let's get in there and just solder this onto one of the other terminals of the switch. Okay. So we've got our battery box in, got a couple of wires now. I think at this point, let's go ahead and start sliding in. Remember, this is going to be the front. This is the front of the robot. So this is going to go in like so. And I think before I get it in too far, we might as well do a little bit of the wiring. I like to use the plastic part that's holding the motor in. There's a little bit of a gap there, and if you feed your wires through there, this is going to help hold It's called wire management. It's going to help hold your wires in an out of the way place. I don't know that it, we don't really know which is forward and backward yet on this. I should have pre-tinned the motor connections while it was all out and more visible. Didn't think of it. So if you guys think of it, do that while it's all out in the open, where you can do it without burning yourself or melting the plastic or anything else. It's this back one on the inside that's going to be the hardest one to get to. My problem is I can't even see it. I know where it is, but I can't see it. Just drag that out of there. I'm going to rotate these feet to a new position to make it easier to get to it. There, now the feet are out of the way and I can actually see it. There. Okay, got at least the motor parts are tinned up. Semi-slip this back into place. Feed the wires through that, if I can get this close enough you can kind of see what I'm talking about. The motor has that clear plastic shroud that holds it in place. Well, on most of them it's clear, not all of them I've noticed. Kind of depends, you know. Point is just a little piece of plastic that is used to hold the motor into the gearbox, and I'm trying to turn it so you guys can see a little bit of what I'm doing. And if we feed the wires through there, we'll do a couple of things. One, it'll make it easier for us to route our wires later so they stay out of the way of the gear, and it'll also kind of work as a strain relief as we're pestering things here so we don't break anything. Soldered the red one on. Like I say, we don't really know if the thing walks backwards. We'll have to reverse these two wires. So we're going to want to test the walking direction here before we go too much further. Kind of fighting this soldering gun cable. Okay. So before we do anything else, let's go ahead and drop some batteries in this puppy and see which way it's going to be walking. I believe that looks like it's going to be backwards, right? Yes. So we do have to reverse those two wires. So in my case, it's going to be black towards the front. You never know on your motors which way that might go. Might be the same. Kind of depends how the motor is wound, the direction that you happen to pop it into that frame. Couple variables there. I'm having trouble finding a way of holding everything and keeping it somewhat in frame. That's not a very good solder connection. Let's try that again. Okay. That should be better. Now, see what you could do is you could take those wires and pull all the extra cabling up to the front so it's not in the back where the gears are, because up in the front you can tuck it down in there and it can't get caught in anything. That black could be pulled a whole lot more. There we go. Okay. sure what I'm fighting right now. I shouldn't be fighting anything. I think I'm okay. I'm going to put the 2 screws through the front of the body and into the mount. Okay. The motor wires, you might need a flat blade screwdriver or something to push and tuck those down in there. Because they're not out of harm's way right now. But I don't want to run in the other room and get a screwdriver. So let's find out how we're doing so far. Okay, well, that's not too bad. We're walking and we have the mouth opening. So you can see as the leg moves in here back and forth, that's what's going to give us our arm action, because as it moves, that goes back and forth. So we start with this claw piece. You'll notice on the back side it has an indent, and in that indent we're going to glue this little fork. Now this arm prints flat on the bed, as you see it, no supports, and this part prints flat on the bed, no supports, and this outer cover for the arm prints flat on the board, just like that, no supports. But now we need to glue these little forks into here. The only reason I made that part separate was so that the part could be done with no supports, to save time, save plastic. Gluing is so quick that there's no reason I couldn't make the part with the fork as part of it. It's just that it ends up taking a whole lot longer to print the part, and to glue something takes seconds. And because it's not particularly load bearing, I mean, all we're doing is moving a cosmetic arm, I don't mind having a glued part on something like that. If for some reason a part was load bearing, then I kind of think twice before I depend upon glue to hold anything, if I have any other way of doing it. Okay, so I think that's already set up. So you can see the point is this fork, when the arm is put in place, goes around that leg. So as that leg moves forward and backward, the arm's going to go in and out. Now what holds the arm itself in place is these outside shield parts. You can see it has a back which is solid, and we're going to put some glue there. This piece travels on the inside, but see, it doesn't go all the way back. So by putting glue there, we don't really have to worry about it spilling over there. And the other place that's safe to glue is up under the arm here. So put a little bit of glue on the part that's going to fit just like that in between the arm and there, because that way it's on the outside and it can't possibly get in to glue that, and a little bit there on the back, and that'll be enough to hold it in place. If we want to put some on the front, we can put a little dab on the outside here, because there's a ridge to help align it that could glue to. So let's just set an arm there. Let's take the part, and we know that we can glue to the back. We know we can glue to the top there and a little bit to the top there. And then I'm going to set it right over that whole assembly. Everything still seems to be free. And where's my zapping stuff? Let's zap that. So the arm should still move free. This piece should be glued on, or gluing on. Let's do the other side. Again, when you take the forks, just line them so they go on either side of that leg piece. We've got our outside arm shell. We know we can put some glue where it hits the rest of the arm, hits that, and across the back. And I just line up the back of the arm flush with the back of the body. Like so. And with any luck, we have arm action, we have head action, we have leg action. We be going. So there you go. Mr. Mech Type 2. Based on my Type 2 cloth walking mechanism that keeps the body level, but the body does raise and lower. Alright. Happy building.